As you can see, we're going to be solving radical equations here today. This is Algebra 2, Unit 4, Lesson 6.5. And one thing that I want you to keep in mind before we start solving equations is what you have solved before. So way back when, you learned that in order to solve an equation like x plus 4 equals 10, let's say, first thing you want to do is you want to think about, well, how do you get the x by itself? So you do the opposite of what's being done to the x. If you have addition, then you're going to do subtraction. You're going to subtract 4 from both sides, and you end up getting the x by itself. If you have subtraction, x minus 6 equals 2, then in order to get the x by itself, you're going to add 6 to both sides. So when you look at this, you get the x by itself because these guys cancel out. Notice that whenever you see addition, you see subtraction. Whenever you see subtraction, you see addition. So addition and subtraction go together. Just like if you were to multiply, so 3x equals 9, then you divide. So you divide when you have a 3 being multiplied by the x. In order to get the x by itself, you would divide. Or if you had the x divided by 4, if you have the x divided by 4, then you would multiply both sides to get the x by itself. So in each of these circumstances, you see you have the opposite always being done. Whenever you have multiplication, you have division. Whenever you have division, you have multiplication. So division and multiplication go together, addition and subtraction go together. And then the next kind of level that you got to is if you had squaring. So if you squared a number, if you squared x and you wanted to get it by itself, you would take the square root. So you would have, whenever you see an x squared, then you would have a square root. And ultimately, you get x by itself. It's the square root of x squared is actually the absolute value of x, which means if absolute value of x equals 2, then x equals plus or minus 2. But you get the x by itself by squaring. When you have x being squared, you're going to take the square root. So squaring and square roots go together, just like cubing. If you have x cubed equals a number, then what you're going to do is you're going to take the cube root. So you always want to be thinking about, so to sum it all up, you always want to be thinking about how do you get the x by itself, or what is the opposite of the operation that's being applied to the x. So the operation, addition, subtraction, multiplication, division, squaring, square root, cubing, cube root. And so it would make sense then if we have a square root that we would need to introduce squaring. And that's exactly what we're going to be doing here. So for example number 1, we have a square root of n equals 7. And so what we're going to do is we're going to square both sides because squaring undoes square root. So the square root of n, quantity squared, is just n. And 7 squared is 49. And with these, that's it really. With these kinds of problems, the main thing is when you square both sides of an equation, that always opens up the door for what we know to be extraneous solutions. So you always want to be checking. All right, you always want to be looking at your solution and you're wondering, did I get an extraneous solution? So you always want to check. Just make sure when you plug it back in that it makes the original equation true. And when it does make the original equation true, we know we found the right solution. All right, go ahead and pause the video and do number 2 on your own. And okay, so here we go. You should have noticed the square root of n. We want to get n by itself, so we're going to square both sides. And when we square 4, we get 16. And when we square the square root of n, we get n. And if n equals 16, then that would mean if we plug it back in, we'd get the square root of 16 is equal to 4. And 4 equals 4, check. So we always want to make sure we check the solution. So good job if you got that. You might even want to try the next few on your own. So number 3 and 4, we see we have the square root of something. That something contains our variable, and therefore we're going to want to square both sides. When you square the square root of something, it undoes what's being square rooted. So the square root of p over 8 squared is just p over 8. 2 squared is 4. And then back to the example we used before, when we have division, we want to introduce multiplication. So when we multiply both sides by 8, the 8's cancel on the left, we get p by itself, and we get p equals 32, and we want to check. Always want to check. And we're going to check p equals 32, so we're going to take the square root of 32 over 8. Does that equal 2? 32 over 8 is 4, just like we learned in a previous section that you can simplify underneath the radical first. And does the square root of 4 equal 2? Yes. So we can safely say that 32, p equals 32 is our solution.